find lengths of missing sides of triangles, right triangles using Pythagorean Theorem. We're going to look at the sides of a triangle and decide whether it's a right triangle, obtuse, acute, or neither, meaning it's not a triangle at all, okay? And I put some rules up here. If c squared is equal to a squared plus b squared, then it's a right triangle. We know that already. That's Pythagorean theorem, right? But if c squared is greater than a squared plus b squared, then it's an obtuse triangle. Greater, obtuse. That's why I put c squared on the left and a squared plus b squared on the right, so it would make it easier to remember. Greater than, obtuse. If c squared is less than a squared plus b squared, then it's an acute triangle. Okay, less than means acute. So you want to compare c squared to a squared plus b squared. Now, the rule for determining whether it's a triangle at all, okay, it's over here on the board. A plus b has to be greater than c in order for it to physically be able to form a triangle. A plus b has to be greater than c. C is your longest side. Okay, C is your longest side. So if you add up the other two sides, they have to be greater than the longest side. Think about it. If you have, let's say, that's 24 inches long. Okay, so 24 is the longest side, right? If my other two sides are only 12 and 12, can that make a triangle physically? If they're only 12 and 12, you can't connect them because they can lay down and they'll just fall on top of that line. If the other two legs are equal to the longest side, you can't physically stand that triangle up. Does that make sense? Are y'all seeing that? That's kind of hard to visualize for some people. Okay? It would collapse. It would fall. Those two legs have to be just a hair longer than that third side in order for you to stand it up a little bit. It can't physically make a triangle if those two legs, if the lengths of those two legs aren't longer than that third side. Does that make sense? Okay. And so that's why c squared has to be greater than c has to be greater than a plus b in order for it to be a triangle at all. Okay? If it's not, then it's not even a triangle. You don't even have to do anything else. Okay. So, let's look at example 1. It says, find the length of the hypotenuse of the right triangle. Tell whether the side lengths form a Pythagorean triple. That's a new word, Pythagorean triple. Pythagorean triple is a special term that means all three sides are whole numbers. All three sides are positive integers. They're whole numbers. They can't be decimals, they can't be radicals, they can't be fractions, they have to be whole numbers. If they are, then it's a special kind of right triangle that's called a Pythagorean triple. So you should have gotten x equals what? 13. And is that a Pythagorean triple? Yes, because it's three whole numbers. So let me actually work it now.
Yes, please. I don't know what.
Okay. So here's my right angle. C is always opposite the right angle. Your hypotenuse is always opposite the right angle. Hypotenuse is always the longest side. So that means this is C. And you can label either the other two A or B. It doesn't matter. Because you're adding those. You're squaring them and then adding them. So it doesn't matter which one you put A and which one you put B. So we'll just do A equals and B equals. Okay? And so C squared equals A squared plus B squared. C squared equals A squared plus B squared. C is X. So X squared equals 5 squared plus 12 squared. Okay? So X squared equals 25 plus 144. So x squared equals 169. Square root both sides, right? Now normally when we square root both sides, we do plus or minus. Do we do that here? Why not? Can't have a negative link, right? So it's only the positive case that we care about. So x equals 13. So 5, 12, and 13, those are all three whole numbers. So yes, it is a Pythagorean triple. Any questions? Is anyone not finished with this work? All right. Try example 2. Now, find the length of the leg of the right triangle. Now, I do not want you to round your answer. I don't want you to round your answer. I want an exact answer. Okay? Which means, for all of these, you'll end up taking the square root of both sides. So you're going to end up with a radical. And you'll have to simplify that radical. Okay? So simplify the radical at the end. Okay, so this is C, because it's opposite the right angle. So we'll just call this A and B. So C squared equals A squared plus B squared. So 14 squared equals 7 squared plus X squared. So 14 squared is 196 equals 49 plus X squared. Then we subtract 49 from both sides, 147. So you get X squared equals 147. And then you have to take the square root of both sides, and we need to simplify that radical. Would y'all guess? I said don't, what is it? 7 square roots of 3. I said don't round it off. You need to simplify the radical. So X equals 7 square roots of 3. Unless it tells you, when we start to find the area of these triangles, your directions will usually specify round, as you find things, round them to the nearest 10 and use that measurement to go on. And so, but if it doesn't say that, your answer needs to be an exact answer, not an approximate answer. 7 square roots of 3. Now, who has trouble simplifying radicals? Especially when they're big numbers. Nobody? Well, then I don't need to tell y'all the trick. Oh, we want to know the trick. Okay. We put it in y equals to find the factors of it, right? That was to find the factors. There's a calculator trick to simplify radicals, sort of along those same lines. So if we want to find the factors of 147, you would do y equals 147 divided by x, right? If you want to simplify the radical, now this works for square roots. I don't know about cube roots and fourth roots. Square roots, you put 147 divided by x squared. And go look at that table. In the table, the x values will represent the number outside the radical, and the y values represent the number underneath the radical. Okay, so put y1 equals 147 divided by x squared. And then go look at the table. You only want to look at the whole number values, the pairings for x and y that are whole numbers. And you'll see 7 and 3. That's 7 square roots of 3. Okay, this set of problems says state if each triangle is acute, obtuse, or right. Now, you won't see any right angle symbols in here because we don't know if it's a right triangle. Okay? And so the first thing you need to do is figure out what is C going to be. Which one of those is C? You can't look at the picture and assume that this is the longest side. Okay? You can't assume that it is. You have to compare it to the other two. C is always the longest side. So this is 7, that's not C. This is 16, it could be. But you need to figure out what's the square root of 208 and compare that to 16 and make sure it's not bigger. So this is approximately 14.4, right? So this has to be C. 16 has to be C. Sometimes they draw these pictures, they don't draw them to scale. So you don't know. Don't ever assume that if it's drawn like it looks like it's the longest side, that it actually is. Because they'll trick you. Okay? You have to know that C has to be the longest side. So because we know that it is, this is C, and we'll call this A and B. Okay, so now we're going to go and compare C squared to A squared plus B squared. Now, when you're plugging in A, B, and C, you do not want to plug in rounded off values. Because we have to know if it's exactly equal to it or if it's greater than or less than. And so if you plug in a rounded off value, you cut off part of the number. Okay? And so we're going to say C squared is what to A squared plus B squared? Don't put the equal sign because you don't know if it's equal. We need to know whether it's less than, greater than, or equal. Okay? And so C is 16. So we say 16 squared is what? To, what's A? 7. 7 squared plus, what's B? Square root of 208 squared. Okay? Now, 16 squared is 256. So 256 is what? 249 plus, what's the square root of 208 squared? 208. 208. Very good. 49 plus 208 is 257. Okay? So compare. 256 is what to 257? Less than. Therefore, remember my symbol for therefore? Well, it's not mine. I didn't make that up. Therefore, it's an acute triangle. Okay, so square root of 17 is approximately equal to 4.1. Square root of 213 is approximately equal to 14.5. So I know this is C, and these are A and B. So C squared is what to A squared plus B squared is the question. So square root of 213 squared is what? 2 square root of 17 squared plus 12 squared. So 213 is what? 217 plus 144. 17 plus 144 is what? 161. So 213 is greater than 161. Therefore, obtuse. Questions? Okay, we already talked about this. C must be greater than A plus B in order for it to be able to form a triangle, and we explained the reasons why. And so some of the problems might say, do the following lengths represent a triangle? Okay, 2, 5, and 7. The longest side is 7, right? So 2 plus 5 has to be greater than 7. It doesn't. It equals 7. So can this be a triangle? No. Because the sides would collapse. They're not long enough to stand up, right? Everybody understand that? Okay. 14, 2, and 20. The longest side is 20. Oh, somebody raise their hand. So 14 plus 2 must be greater than 20, is it? No. So not a triangle. And what about the last one? No. The longest side is 9. 3 plus 1 is not greater than 9. So the answer is no. Not a triangle. Yeah, it is easy. If you understand the concept, sometimes it's hard for people to visualize why that's true. Okay? Any questions? Yes.
So you just take the two smallest ones?
Add them up, and if they have to be bigger than the third. Yes. Okay, now we're going to apply this knowledge to finding the area of triangles. So each one of these problems, since we're in the Pythagorean Theorem section, it stands to reason that you'll be using the Pythagorean Theorem to find the missing links that you need to plug into the area of a triangle formula. What is the area of a triangle formula? Yes, 1/2 base times height, or base times height divided by 2. Do y'all remember why that's the area of a triangle? Because it's half of a square or rectangle. The area of a rectangle is length times width, which is the same thing as base times height. And every rectangle can be divided into 2 triangles. So the area of any triangle is half the area of whatever that rectangle would be. That's how they derived that formula. So it's base times height divided by 2, or 1/2 times base times height, same thing. So when we look at this problem, we see that these two sides are equal. What kind of triangle is that, the big one? Isosceles, right? If it's an isosceles, first of all, what are we missing here to find the area? We're missing the height, correct? Okay, so in order for us to find this, we're going to have to use the Pythagorean theorem on one of these smaller triangles to be able to find that. Okay? Well, in order to use Pythagorean theorem, we need to know what this is. Anybody have a guess? 5. Why?
Subtract 10.
Because
Divide by 2.
you divided by 2, but why? Why is it okay to do that with this? Okay. No, because if I drew a triangle like this and dropped it down, and I told you this whole side was 10, because it's an isosceles, yes, because the two sides are the same, that means the distance from here to here is the same as from here to here. So if they drop this down from the center, it's going to hit directly in the middle of that bottom. Does that make sense? So that means this is congruent to that, which means this is 5 and this is 5. So if it's not an isosceles triangle, you cannot split that base up into 2. Everybody understand that? Okay. But because it is, you can do that. So now we can use one of these small triangles to use the Pythagorean theorem to find h. So y'all go ahead and do that. You have to find h first and then plug it into your area formula to find the area. You have to find the height using Pythagorean theorem and then go find the area. Okay, so we need to find the height. And so c squared equals a squared plus b squared. So c is 7 because it's opposite the right angle. So 7 squared equals, so this is C, A, and B. B is 5. So 7 squared equals h squared plus 5 squared. So 49 equals h squared plus 25. So if you subtract 25 from both sides, you get h squared equals 24. Take the square root, and h is approximately equal to 4.9. Right? So now we go find the area. Area equals 1/2 base times height. So area equals 1/2 times 10 times 4.9. So area is approximately equal to 24.5 what? What's my unit? Meters squared. Area is always squared, volume is always cubed. Okay? Any questions? Yeah, that's fine. Save yourself some work. If you're just plugging it into something else, don't go simplify the radical. If they wanted you to just find the height, then you would simplify the radical. Okay. I got another one, a couple more for you to try. Find the area of the figure. Okay, start with the one on the left. All right? Round decimal answers to the nearest 10. And so if I want to find the area of this whole triangle, I need to know this whole base. And they didn't give me that base. And so the only thing I can do is I can find that base, and then I can find that base and add them together. Or you can find, the base, then you can find the area of this one added to the area of that one. But that's more work. Okay, so to find x, so we need to find x, then we need to find y, and we need to put those together, and then that will be the base for the whole triangle. And so for the left-hand side, we have, this is C, so we have x, we have c squared equals a squared plus b squared. So 5 squared equals 4 squared plus x squared. So 25 equals 16 plus x squared. Subtract 16 from both sides. So 9 equals x squared. So we take the square root, so x equals 3. So this piece right here is 3. Go with me? Okay? Then we do the other one. We find y. So this is c. Now that's a and b. So c squared equals a squared plus b squared. So 8.5 squared equals 4 squared plus y squared. So 8.5 squared, 72.25, equals 16 plus y squared. Subtract 16 from both sides and you get 56.25 equals y squared. We take the square root of both sides and you get y equals 7.5. So this is 7.5. So 3 plus 7.5 is 10.5. So the base of that entire triangle is 10.5. Right? So those of you, are you finding your mistakes? Okay, so now we can find the area. So area equals 1/2 base times height. So area equals 1/2. The base is 10.5 and the height is 4. So area equals 21 square meters. Now, if you did this and you tried to say 5 squared plus 8.5 squared equals c squared. If that's how you try to find the base, you can't do that. Why? Why can't we do that? Why can't we do 5 squared plus 8.5 squared equals? Because it's not a right triangle. It doesn't tell us that it's that big triangle is a right triangle. You can only use Pythagorean theorem on right triangles. Okay? Now, if it had told us, if it did this, then that's how you would find that base. But it doesn't do that. So we cannot use Pythagorean theorem on the big triangle. Okay? Now, I gave you a hint on number 2. So you're going to have to find the area of one triangle and add it to the area of the other triangle. Split this up into that triangle and this triangle. And then add those two areas together. Because they give us the height of this is 8 and the height of this one is 12. And each one of those are isosceles. Okay, remember the one we did where it was isosceles? And if it's isosceles, then that base is directly divided by 2, right? And so, if you find the length of one of these, then you know, you just double it and you'll know the length of that whole base. Everybody see that? Okay. Now, one of the things that you didn't know is that this is called an altitude. If it drops down from the center, if it goes from the center down to the base, it's perpendicular. If it's isosceles, it drops down perpendicular. Okay? So that makes that a right angle. And so we can take this and do Pythagorean theorem and find what that base is, and then we'll know what the whole base is. And so you say c squared equals a squared plus b squared. C is 13. So 13 equals, we're trying to find that. So 12 squared plus x squared. So 13 squared is 169 equals 12 squared is? We subtract 144 from both sides. We get x squared equals 25. Very good. So x equals 5. So that means this is 5. So my whole side is 10. That's the base of both of those triangles. That's the base of this triangle on the left, and that's also the base of this triangle on the right. So now we have everything we need. We're going to find the area of the triangle on the left and then add it to the area of the triangle on the right. So, let's do that. So area equals 1/2 base times height. So area equals 1/2. We already said the base was 10, and the height of the triangle on the left is 12. So 1/2 times 10 times 12 equals 60. So 60 square meters. So this triangle on the left, the area is 60 square meters. That's this triangle. Now we do the same thing with the triangle on the right, and then we add them together. Then we'll know how much paint we need to buy to cover that entire kite-looking figure. We wanted to paint a kite. That's what we would do. Yes. Yeah, that's smart too. She did the area of the triangle on the top, and then you just doubled it, and then double it, and you'll get the area of both of them. That's another way to do it. Yes. Say that again.
do the top, then you don't have to divide it by 2, because it's like,
Oh yeah, if you do the top, then the base is 20 and the height is 5, and then you can just double it. Yeah, that's a great way. Okay. So area equals 1/2 base times height. So area equals 1/2 times, the base is still 10, the height is of the other one is 8, which is 40. So 60 plus 40 equals 100 square meters. So yeah, there's definitely more than one approach to this problem. So did everyone understand the second method to solving this? What they were saying? How they found the area of this top triangle up here? So the base would be 20 and the height would be 5. And so that area is 50. And then the bottom's exactly the same as the top. So if you double it, you get 100. So that was a great way to do it. Probably easier than this method. This route. But there's more than one path. Okay? Any questions? All right, I'm going to give you your worksheet.